Next up is number 4, the histogram about the Midwestern elementary school students. So a group of 78 third grade students in a Midwestern elementary school took a self-concept test that measured how well they felt about themselves. Higher scores indicate more positive self-concepts. A histogram and some summary statistics from Minitab for these students' self-concept scores are given below. So it's important to note when we're looking at this data that we can consider what these values are, as the values are pretty static, right? It's a count of only 78 students, so with some confidence we can kind of see where these lines fall. That's going to be important for some of these questions. So we have a summary of statistics down below. We'll note the variable. The n value is the total students, 78. We have the mean of 56.85, standard deviation, and so on. We're going to use this data as needed to solve A through D. So part A, one student in the group had a self-concept score of 62. Calculate and interpret this student's z-score. Recall that a z-score is equal to the value in question of a particular student minus the mean divided by the standard deviation. To solve in this case, plug in the values as given. 62 is the x value. Our mean is given in the summary at 56.85 divided by the standard deviation of 12.35. Subtract up top, that's a little less than 6, that's 5.15 over 12.35, which gives us the answer that you'll see in the key at 0.417. So the next step is to interpret what this means. We can interpret from this 0.417 is that a score of 62 is 0.417 standard deviations above the mean of 56.85. Answer these questions as directly as you can. We don't need to do any further interpretations, right? The information is kind of just given as it's given. We're just trying to summarize what the data means. Part B, interpret the standard deviation. The standard deviation given here is 12.35. The best way to interpret these values is to include 12.35 and the mean of 56.85 in our solution, or rather in our explanation. So let's go ahead and set this up nicely. So what are we going to say? The students' self-concept scores always go back to what the x value is, or what the values being measured is. Use that to guide your answer. So the students' self-concept scores typically vary, right? Standard deviation is just the varying of the data. Varies by 12.35 from the mean of 56.85. See how simple that is? Just lay it out, very straightforward. You don't have to go into any longer details, just speak to what the data says. All right, next up, C. What percentage of the third graders scored less than 30 on the self-concept test? This is going to be the step where I mentioned we can kind of gauge from the data where these values fall. A score less than 30 is right about here. There's the cutoff at 30. Right, so we're going to look at 30. That's the cutoff. How many data points are less than 30? Well, just by estimating it, we can see that there's 1 in the 20 to 25 bracket and 2 in the 25 to 30 bracket. I know it's not an exact here, but you can use some inference to determine that these values would be 4. There's clearly going to be another marker here that's 3, and that's about it. So then we can add up the total number of students. So there's 3 total students here, less than 30. There's 1 and there's 2 here. So it says what percentage of the third graders scored less than 30? That's 3 out of the total 78 students. which gives us 0.038 or 3.8%. Last on this list is part D, which says use the rule to check if 84 is an outlier. Recall how the outliers work. We need to take Q1 and subtract what value? 1.5 times the IQR, the interquartile range. That's going to be the less than values. Q3 plus 1.5 times the IQR is going to be the greater than values, or the, where's the upper limit of our outliers and where's the lower limit of our outliers. For this problem, since we're dealing with a value at 84, that's going to be about here on the graph. You'll notice we don't need the first calculation. We just need Q3 plus 1.5 times the IQR. Let's off to the side here. Let's figure out the IQR. That's equal to Q3 minus Q1. So that's going to be 65 minus 50, or 15. Q3 is 65, so we have 65 plus 1.5 times 15. That's 65 plus 15 and 15 is 225, so 22.5. And we get an upper limit of 87.5. So, is 84 an outlier? No, our outlier upper limit is 87.5, and our nice value of 84 falls well enough below. So the outlier upper limit is 87.5. If we are less than 87.5, it is not an outlier. So the last step in a free response question, we need to make sure we state that. Okay, so what are we going to state? No, 84 is not an outlier because it is less than the outlier upper limit of 87.5. That would be a solid enough answer that not only checks if 84 is an outlier, it gives a brief explanation as to why. And that's it.